Hi, everyone. What impact can symmetry, skewness, and outliers have on means and medians? All right, we'll take a look at this symmetric distribution over here. It's perfectly symmetric. You can think of this as a smoothed out histogram of test scores. Now, over here, notice that the mean and the median are exactly the same, 75 points. If you have a perfectly symmetric distribution, the mean and the median will coincide. They'll be the same score in points. Now, if the distribution is pretty close to symmetric, is approximately symmetric, and if there are no outliers, then the mean should be close to the median. So if you basically have symmetry and there aren't extreme outliers, extreme values, then the mean should be close to the median. Again, outliers could change that. As we've seen before, outliers could change that. In particular, outliers can drag the mean away from the median. That's where skewness comes in. All right, so let's say that you have a histogram of test scores that smoothed out looks like this. Remember, this is left skewness. Skewness follows the tail. We have a left tail here. Kind of like quiz 1 in a class where most of the students do pretty well, but you have a long tail of students who just aren't prepared for the class or who don't study. And these are students who may drop throughout the semester. Now, the left skewness of this distribution is pulling the mean lower than the median. Okay, so the mean here is being pulled by this tail lower than the median. So the median is very stable. The median separates the bottom 50% from the top 50%. But because of the skewness, because of all these extremely low values here, maybe including some outliers, because of this long left tail here, the mean is being dragged to the left, lower than the median. So the very low values are pulling the mean to the left. Now I have a question for you. Think about it. What typically happens to exam means and medians as the term progresses and students drop out of the class? Again, some dark humor here. If I put a big X over here and allow these students to drop, what happens to the median and the mean? Well, the median should rise a bit, okay? So the new median might be over here. I'll put this in green. The new median might be over here, okay? But the mean should be a lot closer to the median. I'll put that in red again. The new mean should be closer to the median. So if the tail starts to get lopped off, and as we move away from skewness and more towards symmetry perhaps, the mean and the median should start to converge. They should get closer together. So if we're going from skewness towards symmetry perhaps, we would expect that the mean will get closer to the median and they would both rise. The mean and the median should generally get closer and they should both rise. In my experience as a TA and a teacher, I've seen that generally happen, where both the mean and the median overall would rise, and the mean and the median would tend to get closer together. All right. For a right skew distribution, a physics class, okay, the skewness over to the right skewness would tend to pull the mean to the right, above the median. Okay, so the very high values would tend to pull the mean to the right. So I guess hypothetically, if a bunch of these students in the right tail go, hey, this physics class is too easy for us, let's take the next physics class up, then I suppose the mean would converge towards the median, and then both of these would go down. Although in practice, that doesn't happen so often. More often I see this happening, where students over in the left tail drop out, and the mean and the median both rise and get closer together. So again, skewness tends to pull the mean away from the median towards the tail, but if the tail starts to drop off, then the mean and the median tend to converge. So now the mean may be better than the median for roughly symmetric distributions. They should be similar anyway, right? The mean and the median should be very similar anyway for symmetric distributions. And the mean is probably better because the mean is more often used in formulas than the median, mode, and the mid-range are. Also, I'm assuming that there are no extreme outliers. Outliers can also mess things up. Okay, so the mean may be better than the median for roughly symmetric distributions, especially if there are few, if any, outliers. Okay, because the mean is more often used in formulas. It's more natural, mathematically. But the median may be more appropriate than the mean as a measure of center for skewed distributions. Okay, like for example, on a first exam. I'll do this in purple. On a first exam, on a first quiz, the distribution may look more like that. And then the students might be going, well, you know what? The people at the lower end may end up dropping anyway. So perhaps the median would be a better measure of the center than the mean is, because the mean may be too impacted, maybe too affected by students who may not be in the class by the end anyway. So the median may be more appropriate than the mean as a measure of center for skewed distributions. Although, as long as there's no fraud and the median and the mean are computed appropriately, I cannot say that the median is wrong or the mean is wrong. I'm just making some arguments, some pro and con arguments for and against the median and the mean. I'm not saying that one is necessarily outright wrong and that the other is necessarily outright correct. There are arguments to be made for or against either. So the median may be more appropriate than the mean as a measure of center for skewed distributions, and also if there are outliers. Okay, that would tend to make us prefer the median because outliers can have a weird effect on the mean, as we've seen before. Remember, here, when we dropped the 70 down to a 0, the mean went from 86 points all the way down to 72 points. So outliers can have a great impact on the mean, the mid-range, not so much the mode or the median. A minor footnote here. Remember, the sample mean is often denoted by x bar. The median is sometimes denoted by x tilde, that squiggle on top. The mode sometimes denoted by x hat. But those are fairly rare. The key thing is remember that the sample mean of a sample data set is given by x bar. In the next lesson, we're going to have more fun with means. In particular, weighted means like your GPA. That's next time.